This is Geometry, Semester 1. It's the second unit on angles, and it's the fifth lesson, Angles of Shapes and with Diagonals Practice. All right, so it's on CreatorMathcom. You might have to type into Google to find it, and it's under the Geometry tab. The instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. Just to try to model that. So here's where you're trying to go, creatormath.weebly.com. Here's the home page. Looks like this. Anything for composition book stuff, you guys, scroll down on this home page, it's all there. But when we want to get into actual notes, video lessons, problem sets, vocabulary, we click the Geometry tab in this case. We're going to pass by this PDF of all the vocabulary for the whole school year. We're going to pass by this semester and go for the one we want. Here we go, Semester 1 in this case, and this says Table of Contents. Make sure you have copied this already onto pages 2 through 6 of your composition book. You're going to copy every one of these lines onto one line in your comp book. We're going to go down to Angles, and we're going down to number 5, Angles of Shapes and with Diagonals. Here's the page numbers it goes on in your comp book. These are the notes. And you guys don't use these page numbers. Use the page numbers on the actual table of contents when you're watching this, because by the time you watch this video, it's going to be different. All right. Sorry about that. I don't know how to handle that. But just to show you where to find it is what I'm trying to do right now. Open up these notes. Sometimes it takes me twice to open them, to load them. It's going to explain to you, here's a square with diagonals across. A diagonal is a line segment going from one vertex to the other vertex. There's a diagonal here and a diagonal here. And these diagonals have characteristics depending if we're talking about a square or rectangle or a trapezoid or a rhombus, etc. So we're going to explore that now. In a square, you know, all four of the vertices measure 90 degrees. It also turns out that the intersection of the diagonals is 90 degrees. That's kind of cool. And these angles here are split, some different things. I'm going to let you copy these notes into your comp book before you do the problem sets. Let's say base angles are split. Okay, this is a rhombus. It splits the angles as these things, diagonals cut across, and it also creates 90 degrees at the center of this shape. This is a parallelogram. Parallelogram has alternate interior angles equal. So we're going to even go into that next lesson when we talk about parallel lines cut by a transversal. But if this is a parallel line to this one, and this is a transversal here, this angle is equal to this one, this angle is equal to that one. So they're called alternate interior angles. Isosceles trapezoid has two equal side lengths, and it's got all these angles equal. It's got equal base angles, both sets of them, because these pairs are matching up. It's got equal base angles on the top too. Remember, I always ask, why is this called a base and this called a base in a trapezoid? And my geometry teacher explained you could flip that shape upside down, so neither of those sides is at the base or bottom, so we call them both bases. It made sense to me. I remember it to this day. All right, let's see, what else we got? Recitals, vocab, split means to divide, usually in half. Diagonals go from one vertex to another. A vertex is an angle in geometry. Plural of vertex is vertices. Here are some sample problems you're going to put into your comp book and go ahead and solve if you can. Otherwise, we're going to do these problem sets, and you're going to do these too, and copy these in your comp book. So, first shape looks like a rectangle. It's telling us an angle measure. Remember, this symbol means angle, so CBD equals 35 degrees. We're going to track that out. Start with the C, find where B is, and D, and go like this. CB, D. So they're talking about right here is 35 degrees. So what is angle ABD? So let's look here and go ABD. Angle, here's A, and here's B, and here's D. Okay, so this one here. Well, in a rectangle, this corner is 90 degrees. So we want to make this X. So what plus 35 equals 90? It's going to be 55 degrees. 55 plus 35 equals 90. Not too bad to start off with. Given the following rectangle. Okay, now they're back on CBD. Now I can go a little bit faster because I know where CBD is. 35 degrees. Okay, same thing. What's angle ADB? So A DB is this one here, question mark, right? Well, these are two parallel lines cut by a transversal here, and alternate interior angles are equal. So this is 35 degrees also. Given a rectangle, all right, we have CBD again. I like it when they give me the same one. I don't have to trace it out. Let's see, 35 degrees. Now, angle BDC. Let's go slower here. BDC. So now we go here. Question mark. So pull this out. What shape do we have here? Pull this out. This line's here, right? This one's here, and this is this one here, the diagonal. And so we have a triangle. What kind of triangle? Well, this is a rectangle, so it's 90 in the corner. If it's 90 in the corner, it's 90 here. This is a right triangle. If this is 35 here, we want all three angles to equal 180. 90, and just these two have to be 90, right? So what does this have to be to add to 35 to be 90? Well, it's got to be 55 again. 55 degrees plus 35 is 90. 90 plus 90 is 180. 55. Get all that in there. All right. Given the following parallelograms, all right, can't talk. Angle CBD is x plus 40. So here's CBD again. All right. X plus 40. And angle ADB is 2x plus 18. So wait, ADB. Here. So this one here is 2x plus 18. So these also, if you have two parallel lines cut by a transversal, the alternate interior angles are equal. So we have x plus 40 equals 2x plus 18. And we're going to subtract x's. We're going to solve for x. Whoops. 2x minus x leaves you with an x. 40 on this side still, plus 18 on this side still. Sorry about my squibbles there. So we're going to subtract 18 from both sides. X equals, we're going in reverse, but it doesn't matter, an equation statement can be flipped. 40 minus 18 is 22. So x equals 22 in this case. They're not asking us the actual measure, they're just asking what is x. Given the following square. Angle BCA. Okay, BCA. So let's trace it out. BCA. This one is 7x plus 3. What's x? What's x? Oh, well, look at this. Okay, in a square, we know that this angle is 90 degrees. In a square, when you draw a diagonal, it cuts this in two. So we know that 7x plus 3 is equal to 90 cut in 2, 45. Minus 3 from both sides. 45 minus 3 is 42. Is 7x. They made it come out nice for us. Okay? Because 42 divided by 7 is 6. And that's what x is, right? And then notice if you plug in 6, 7 times 6 is 42, plus 3 is 45, right? And 45 plus 45 is 90. So you can always trace back to check your answer. All right, there we go. Focus a little. Given the following rhombus, a rhombus is a pushed over square, almost as if someone took a square and went and pushed one side over. Angle BAC is 5x plus 1. Where is BAC? BAC. Here we go. Here. Here, BAC is 5x plus 1. And CAD is 8x minus 20. All right. So we're trying to figure out what these are. Oh, they're equal. So we're putting them equal to each other. All right. 5x plus 1 equals 8x minus 20. Now we're solving for x. I'm going to subtract the smaller number of x's from both sides. That way I end up with a positive x value. So 8x minus 5x is 3x. If I'd gone the other route, I would have taken 8x from 5x and would add a negative 3x. And that just gets a little messy. So if I can plan it out like this, I will. I subtracted the smaller number of x's from both sides. So 3x minus 20 equals, we still have a 1. Let's add 20 to both sides. All right, 3x equals 21. divide by 3 on both sides. I'm going to switch the x over here and this over to here. 21 divided by 3 is 7. Given the following isosceles trapezoid. So they don't show you tick marks here, but there's tick marks here. These sides are equal length. CAD. CAD. There we go. CAD is 25 degrees. What's CBD? CBD is up here. Okay, so the question mark here. Well, here's why it's going to be 25 degrees. Base angles of an isosceles trapezoid are equal, including these in here. All right, so if this is 25, this is 25. The bases of an isosceles trapezoid, of any trapezoid, are actually parallel, and this is a transversal cutting across, and so alternate interior angles are equal. 25 degrees. Given the following kite, K-I-T-E, AE is, this is AE here, 2x plus 20. And this is x plus 40 here. Well, the way it works in a kite is these diagonals cut each other in half. So this one across here is this is equal length to this. And this one's not true. That doesn't cut in half. But this is an equal length to this. And this is an equal length to this. I believe check the notes, and I hope that's in there. Anyway, these two are equal to each other. So we get 2x plus 20 equals x plus 40. Subtract the smaller number of x's from both sides. 2x minus x is x plus 20 equals 40. Subtract 20 from both sides, and x equals 40 minus 20 is 20. All right, what else we got? Given the following rhombus, if angle BCE, 4x minus 7. So this is a rhombus. It's a pushed over square. These two things are equal. These two things are equal. Angles. These two angles are equal to each other. These two angles are equal to each other. And ACD, so ACD goes here, here, is 2x plus 7. So they got to be equal to each other. So we got 4x minus 7 equals 2x plus 7. Subtract the smaller number of x's from both sides, and you get 2x minus 7 equals 7. Add 7 to both sides, and 2x equals 14. Divide both sides by 2, and x equals 7. All right. This one's interesting. Let's see. Given the following rhombus, BAC is 3x plus 10. BAC is here. 3x plus 10 is here. And then, I don't know what this is. I'm going to fix this and make it right. Is 2x plus 20, and it's going to come out to be 10, you guys. The answer is going to be 10, and I'll fix it, and I'll show you this work later. All right? Given the following square, if angle BEC is 3x plus 45. Here, what is x? Well, we know that this is 90 degrees here, right? That's what happens in a square when you have diagonals. They cross at, they intersect at 90 degrees. So 3x plus 45 equals 90, minus 45 from both sides. 3x equals 45, 90 minus 45 equals 45. Divide both sides by 3, and x equals 15. Given the following square, if BEC is, so BEC here again, 3x plus 45, what is angle CED? CED here. Well, I know it's 90. It looks like a trick question. It's got to be 90 degrees because this, you know, they intersect at 90 and they intersect at 90. That is what it is. So, okay. I don't know what's up with that one. That was kind of a trick question maybe. Okay. So given the following isosceles trapezoid, this side's equal to this one. If CAD is, let's see, CAD is 9, so CAD is here. 9x minus 77, and BDA is here, 3x plus 7. These are equal because base angles of an isosceles trapezoid are equal. So we have 9x minus 77 must be equal to 3x plus 7. We just place them equal. Subtract the smaller number of x's from both sides. 6x minus 77 equals 7 plus 77 plus 77. 6x equals 77 plus 7 is 84. 84 divided by 6 divided by 6. X equals 14 maybe? Just a model for you. I don't always know my 14s, right? And you may not either. Go back. I guess I don't need to go back. Just go into the calculator and say 84 divided by 6. 84 divided by 6. Yep, I got it right. 14, 14. Don't be afraid to use the calculator to help you guys. Right? Make sure you're tracking the right title of this, Geometry Semester 1. It's the unit on angles, unit number 2, and it's the 5th lesson, Angles of Shapes and with Diagonals Practice. It's on CreatorMathcom under the Geometry tab. Hope that helps.